Hello everyone, and thank you for having us. I would like to present my paper on harnessing digital twins for construction site management. My name is Ahmad AL Ayoubi. I'm a PhD student at Virginia Tech, and I wrote this paper alongside my co-author and advisor, Assistant Professor Dr. Ashtarout Ammar. So to start with, while conducting our research, it was apparent that digital twins had a huge potential in the construction site industry, but lacked real-life applications. Most studies are either limited in application or theoretical in base. So for this paper, we wanted to study how digital twins can help with the on-site efficiency and contribute to decarbonization goals. Our research objective for this paper consists of three parts. So the first one is an overview of digital twin implementations in the construction industry. Second one is to analyze how digital twins benefit site operation. And finally, to explore its decarbonization applications. So how did we go around doing it? Well, first of all, we followed the Prisma framework where we started by screening industry articles, then conducted a systematic search using databases Web of Science and Google Scholar. Then we refined our search string to reduce the number of redundant papers that are not relevant to our topic. Then we applied filters and criteria such as only English papers and papers published after 2018. Then we extracted those, ending up with 80 articles total. And after we took these 80 articles, we read the full text and ended up with 50 articles ready for review and analysis. So the results we ended up with are the following. We ended up with 4 key functions for digital twin operations. First one being real-time feedback and data. Second one being predictive analytics. Third one being simulation and optimization. And finally, collaborative decision making. Now, these results, when applied simultaneously on site, they result in multiple applications, of which we covered only 8. And these 8 are safety management, logistics optimization, emissions monitoring, quality assurance, real-time decision support, environmental impact tracking, digital collaboration, and finally productive monitoring. So I will start with the general key functions of digital twins in the construction industry, specifically in on-site conditions. I will be listing them, and then I'll be talking about the description, their benefits, and their decarbonization impact. To start with the first one, real-time monitoring. It provides continuous visibility into on-site processes. It enables real-time tracking of conditions, and it tracks emissions and fuel consumption. Predictive analytics, it predicts potential failures and shortages, where it allows for timely interventions and maintenance, where we can optimize equipment health for less fuel use. Simulation and optimization. Digital twins can optimize workflows and validate designs. It can identify inefficiencies and optimize resource allocations and minimize energy consumption through scheduling. Finally, for collaborative decision making, digital twin can provide a unified platform for sharing data. It can simulate environment changes for optimization, and it can reduce site visits and speed up actions. Now, for the applications, as we said, we ended up with 8. First one being safety management, where digital twins enhances safety through real-time monitoring and hazard prevention. Second of all is logistics management, where digital twins streamlines material tracking and reduces waste. Emissions management, where it reduces energy consumption and carbon emissions. Quality assurance, where it detects defects early on in the life cycle of the project and ensures product stability. Decision support, where it improves planning and risk management. Environmental monitoring, where it manages dust, noise, and vibration levels. Collaboration, where digital twin fosters communication and conflict resolution. And finally, it's productivity tracking, where digital twin optimizes worker performance and health by, for example, wearing harnesses, sensors, or monitors. To discuss the functionalities and the relationship between the key applications and the key functions of digital twins, we're going to be listing each of them, and we're going to show how each application is related to each key function. So the four key functions that we talked about previously are real-time monitoring and feedback, simulation and optimization, collaborative decision-making, and predictive analytics. And these are the general applications. The general applications that we discussed are a total of 8. And in this slide, we're going to be showing where each function is applied in each application. So, for example, real-time monitoring and feedback is applied in dust and noise and vibration monitoring. It's applied in logistics and material management. It's also applied in real-time worker productivity and tracking. The simulation and optimization is applied in quality assurance and defect detection. It's applied in safety management, and it's also applied in emissions and energy management. For collaborative decision making, it's applied in logistics and material management, in quality assurance and defect detection, and in real-time worker productivity and tracking. As for the predictive analytics, it's applied in logistics and material management. It's applied in quality assurance and defect detection, and finally in real-time decision support. Now, how do these relate to decarbonization? The decarbonization goals that we talked about in the paper are renewable energy, carbon emissions, equipment health, and material waste and recycling. So, for example, if we take dust and noise and vibration monitoring in the general application, it helps with renewable energy, it helps with carbon emissions, and it helps with equipment health. If we take emissions and energy management, then it will help with the renewable energy. It will contribute to the decrease in carbon emissions and with the equipment health. If we take logistics and material management for collaborative decision making, then it will help with material waste and recycling. It will help with equipment health and with carbon emissions. For the predictive analytics, the logistics and material management, quality assurance and defect detection, real-time decision support will also contribute to renewable energy. They will contribute to carbon emissions and equipment health as well. Thank you very much. Finally, I'll be talking about limitations and future studies. Future research into digital twins is essential to unlock their full potential, where it can enable scalability, data-driven solutions to enhance productivity and accelerate sustainability goals in modern site operations, specifically in the construction industry. So there are 4 main avenues for the future research. First of all is achieving full integration, where you have to integrate digital twins to drive innovation and sustainability. Building on current foundations, leveraging existing implementations to identify the gaps in literature, gaps in applications, and so on, and opportunities. Establishing standardization, developing a standardized framework for seamless data exchange. Improving interoperability by enhancing and maximizing automation and predictive capabilities, because currently on site, most operations are using legacy systems. So by improving interoperability, we'll be able to further and easier integrate digital twins into everyday operation. Thank you again for having us. If you have any further questions, please feel free to reach out, and take care.